Hi everyone in Algebra 2B. Today we're going to be going over your questions for lesson 110A. Starting on number 1. So we have RJ and Chang noted that the sum of the digits of their two-digit counting number was 9. If the digits were reversed, they found that the new number was 27 less than the original number. What was the original number? So for this problem, what we need to know is we need to know what the original and what the new number equations are. And if you don't have those written down, you should have them written down. And that's from lesson 107. So I will pull those notes out when we're ready. But it says the sum was 9. So that means the tens plus the units digit equals 9. Then it says when the digits are reversed, then they found the new number. So the new number formula is here, which is 10u plus t. The new number was 27 less than the original number. The original number is 10t plus u, and it says 27 less than that. So now I have two equations. I'm going to start by moving, well, I can move the t over here, move the u over here, and move the 27 over here. And I would end up with 27 is equal to 9t minus 9u. And now what I can do is I can do elimination with the original equation. So I'm going to multiply this one by 9. And I would get 81 equals 9t plus 9u. And we're going to add those together. So the u's are going to cancel. And I get 18t is equal to 27 plus 81, which is 108. And when I divide that by 18, I get 6. So I know that t is equal to 6. And then to solve for u, I'm going to plug it into there. So I have 6 plus u equals 9, so therefore u is equal to 3. And they asked us for what the original number is. And if the original number has a 6 in the tens digit and 3 in the units digit, the original number is going to be 63. Now moving on to number 2. It says Susan had a two-digit counting number and the sum of the digits was 7. If she reversed the digits, she found that the new number was 45 greater than the original number. What was the original number? So again, we have the sum adds up to 7, so t plus u equals 7. Then it says when the digits are reversed, the new number, so new number is always 10u plus t, is 45 greater than the original. Original is always 10t plus u, and it said 47 greater than that. So again, you have to know those formulas. Now I'm going to bring the 10t to the left, bring the u to the left, and I end up with 9u minus 9t is equal to 47. I'm going to do elimination again, so I'm going to multiply this equation by 9, and that would give you 9u plus 9t is equal to 63. Now this time our t's are going to cancel, and I'm going to get 18u is equal to 47 plus 63, which is 110. This should have been 45 greater. I'm so bad, sorry. So this actually should have been 108, my bad. So again, we're going to do 108 divided by 18, which gives you u is equal to 6. Then to solve for t, I'm going to plug it into this equation. So that'd be t plus 6 equals 7. So that means t is equal to 1. And the original number, if the tens digit is 1 and the units digit is 6, is going to be 16. Now looking at number 3, we have the weight of oxygen and a quantity of an ideal gas was 336 grams. What was the total weight of the compound? So I have K, CR2, O7, and then I'm going to have total. Okay, so K, potassium weighs 39. Our CR is going to be 2 times 52, which would be 104. Our oxygen is going to be 7 times 16, would be 112. And we have to add those together. So 112 plus 104 plus 39 equals 255. And it says that the weight of oxygen was 336. And we want to find out what the total is here, X. So now you're going to cross multiply. So I'm going to have 112 X is equal to 255 times 336, and divide both sides by 112. And you're going to get 255 times 336 divided by 112 gives me X is equal to 765 grams. And that is your result. Now moving on to number 4, we have the Delta Queen could go 120 miles downstream in 8 hours, but it took her 9 hours to go 63 miles upstream. What was her speed in still water, and what was the speed of the current in the river? So that means that the boat, we have the distance going downstream is going to be equal to 120. We have the time downstream is 8. We have the distance upstream is 63. And we know the time upstream is equal to 9. So we have two formulas. We have our downstream equation, which is going to be B plus W times TD equals DD. And then we have our upstream equation, which would be B minus W times TU equals DU. I'm going to input my 8 and 120 into the first equation, so that would be B plus W times 8 equals 120. You can distribute the 8. So we get 8B plus 8W equals 120. Then for this one, we would have B minus W times 9 equals 63. Distribute that. So that'd be 9B minus 9W equals 63. Now what I would do is I would actually simplify this equation, because all of those are divisible by 8 and all of these are divisible by 9. So in this equation, that would leave me with B plus W is equal to 120 divided by 8, which is 15. And on this equation over here, I would end up with B minus W is equal to 63 divided by 9, which is 7. And now I'm just going to add these two equations together, because our W's are going to cancel, and you end up with 2B is equal to 22. So that means my speed of my boat is going to be 11. And then when I solve for W, I have 11 plus W equals 15. So that means the speed of the current is going to be 4. And that is it. Now, if you didn't simplify those equations, that's fine. It still works the same way. So don't worry if you didn't do that. Now, moving on to number 5, we have Steve and Susie found that the cost of the machine was $1,400 and that it was marked up $700 over what it cost. What was the markup as a percentage of selling price, and what was the markup as a percentage of the cost? So the cost of the machine was $1,400. The markup was $700. So what we're going to do here is we have the cost of the machine. So selling price equals purchase price plus markup. So it says that the cost of the machine was $1,400 and that it was marked up $700 over what it cost. So that means that the purchase price was going to be $1,400 and we are given the $700 markup, which means that the selling price is going to be $2,100. Now, markup is going to be either the percent of the selling price or the percent of the purchase price. And remember, we always put percent over 100. And they give us that this markup is equal to 700. So now what I'm going to do is I know what the selling price is and I know what the purchase price is. So I'm going to fill that in. So that would be percent over 100 times 2,100 equals 700. And this would be percent over 100 times 1,400 equals 700. So essentially what I'm doing is these zeros would cancel on both of these. So really what I'm doing for this one is I'm going to divide 700 by 21, which gives me 33.33%. So that would be 33.33% of the selling price. And for this one over here, it's going to be 700 divided by 14, which is going to be 50% of the purchase price. So make sure you read through that problem carefully. Sometimes it's a little tricky. Even I got tripped up by that one. Now moving on to number 13. So I'm going to start by setting n equal to 0.01362 362. Now, because there's 3 repeating decimals, I have to multiply this by 1,000. So it's going to be 1,000 n is equal to 1, 2, 3, which would become 13.62362, and just repeat. Now, when I subtract these two equations together, the repeating decimal and the 362 are going to cancel. And now when I do 1,000 minus n would be 999n is equal to 13.62 minus 0.01, which is 13.61. And you're going to divide both sides by 999. But you do need to get rid of that decimal place in the numerator. So you're going to move the decimal over two spaces, so that you are going to end up with 1,361 over 99,900. And that concludes number 13. Now looking at number 14, the first thing that I'm going to do is I am actually going to put all the x's in parentheses. And then leave the +3 on the outside. Now when I complete this square, that's going to be x minus 2 squared. So if I add 4, I have to do the opposite to the outside, which would be subtract 4. That would be -1. Now because there is no minus sign on the outside, I know that this parabola is going to face up like this. This is the axis of symmetry, so I'm going to set x minus 2 equals 0, and that would give me x is equal to 2. And this right here is my vertex. So I'm going to go to +2 and put in a dotted line. Then I'm going to go down 1 to put my vertex. Now if you remember the chart, it's over 1, up 1 in either direction, and then over 2, up 1, 2, 3, 4 in either direction. And then you connect the dots. So think 1, and then 1 squared is 1. And then think 2, and then 2 squared is 1. And that is your result for number 14. And if you wanted to check your notes, that was from lesson 100. Now what we're going to do for number 15 is I'm going to start with this inequality. When there's a slash through it, I need to flip it and take away the equal sign. So that means 3 is going to be greater than x plus 2. Move the 2 to the other side. 1 is greater than x. I am going to flip that. So that would be x is less than 1. Now I work on another one. I have to flip this inequality and add an equal sign. So that would be x plus 5 is greater than or equal to 8. Subtract the 5. So I get x is greater than or equal to 3. And the domain is real, so this is going to be a point with an arrow, not just dots. So now I have my 2 endpoints, so I'm going to go -1, 0, 1, 2. So on 1, my dot is going to be open because it's not equal to 1. And on 3, my dot is going to be closed. It says greater than 3, so that means I'm going to fill in to the right of 3. And then on 1, it's to the left of 1, so I'm going to fill in everything to the left of 1. And that should conclude all of your questions from lesson 110A. I hope you guys all have a great day. Bye.